Have you ever stepped onto a freshly upgraded train? Or maybe one of those sleek new metro cars that are popping up in major cities, and you just sort of stop to look around?
Yeah, the ones that actually feel modern, right?
Exactly. You notice the automated doors sliding perfectly shut with that satisfying mechanical click.
Oh, I love that sound.
Right. And you see the ergonomic seating, the modular LED lighting built right into the ceiling, those pristine, vandal-resistant modular toilets. And, well, if you're anything like me, you find yourself wondering about the massive, almost entirely hidden ecosystem that makes that physical transformation possible.
It's totally hidden in plain sight.
It really is. So today's deep dive pulls back the curtain on this exact world, and we're using the remarkable trajectory of Airfloa Rail Technology Limited as our lens.
Which is such a fascinating industrial space because it's a world every single one of us interacts with, but we rarely give it a second thought. We see the finished train pulling into the station, but we absolutely do not see the sprawling, incredibly complex, and honestly heavily bureaucratic supply chain required to put that train on the tracks.
Yeah, and our mission for this deep dive goes far beyond just looking at a single manufacturing company. We're exploring the anatomy of a massive, multi-decade industrial upgrade cycle happening right now across India.
A massive cycle.
We're going to break down the mechanics of how a company transitions from making, isolated individual train parts to becoming a master system integrator.
Which is a huge leap.
Right. We'll dig into what actually happens on the factory floor when they attempt to apply those exact same metal bending skills to aerospace and defense. And perhaps most importantly, we're going to expose the hidden, really agonizing financial traps of working with government mega projects.
Yeah, because you're looking at a business navigating a brutal trifecta. It's high-tech precision manufacturing, ravenous capital requirements, and the famously slow wheels of government bureaucracy all happening simultaneously.
So let's set the stage here. Airfloa Rail Technology was established back in 1998. At their core, they build railway rolling stock components and interiors.
Right. The stuff inside the train.
Exactly. We're talking about everything from the doors and the windows to the seats, the modular toilets, and now full interior fit-outs.
The whole package.
Yeah, and we're going to explore why their specific place in the value chain matters, how they actually generate their revenue, and what the underlying numbers reveal about their runway for the future.
Which is the most interesting part.
Definitely. But to frame this properly, I want you to think about it like this. When you decide to remodel your house, you don't just drive to the hardware store, buy a pile of wood and a box of nails, dump them in your living room, and hope for the best.
Well, I mean, you shouldn't.
Right, you'd end up with a disaster. You hire a master contractor, you hire someone whose entire job is to integrate the plumbing, the flooring, the electrical, and the lighting so it all works together perfectly. Airfloa is basically trying to be that master contractor, but for passenger trains.
The contractor analogy is really helpful, but we need to scale it up massively.
How so?
Because if you mess up a home renovation, you have a leaky sink. If airflow messes up the integration of a train's interior, you have panels rattling at 130 kilometers per hour. Or worse, automated doors failing with 1,000 passengers on board.
Wow, yeah, the stakes are just a bit higher.
Just a bit. And to understand why that contractor role is so vital to their business model, we have to look at the entity they're doing the contracting for. Their anchor customer.
Right, their lifeblood.
Exactly. The absolute undisputed core of their business is Indian Railways. The numbers show Indian Railways accounts for roughly 80% of Airflow's turnover.
80%. Wait, I have to stop right there because that is a terrifying level of concentration.
It is high, yes.
Having one single customer account for 80% of your business usually means you aren't really an independent company. You're just an outsourced department of your client.
It undeniably creates a massive single point of failure risk. If Indian Railways changes its procurement policy or delays a major rollout, Airflow feels the pain immediately.
They catch a massive cold if the government even sneezes.
Precisely. Now, they do supply to other entities to diversify somewhat. They work with the Mumbai Railway Vikas Corporation, MRVC. They supply the Kolkata Metro.
Okay, so a few other pots on the stove.
Right. They also work with major global and domestic original equipment manufacturers, the OEMs, players like Alstom, Siemens, Titagar, and RVNL. But make no mistake, the center of gravity is Indian Railways.
And what they're actually supplying to that behemoth has evolved dramatically since 1998. This is an important distinction to make early on. Airflow isn't a software company.
Not at all.
They don't make money from subscriptions. They don't have recurring software as a service revenue. This is pure, heavy industrial execution. They bend metal, they mold composites, and they execute integrated coach interior jobs.
And the evolution of those jobs really tells the story of their ambition. They started out manufacturing HVAC-related parts. Heating, ventilation, air conditioning.
Like the basic stuff?
Yeah, relatively basic components, air filters, simple ducting, basic sidewalls. It's commoditized work, but they have aggressively moved up the complexity ladder.
Which is hard to do in manufacturing.
Very hard. They transitioned into automated doors, which requires integrating sensors, motors, and strict safety protocols. And now they've moved even further up to full coach integration.
I want to spend some time on this shift up the value chain, because moving from a component supplier to a system integrator feels like a monumental leap. The company described executing what are called turnkey interior furnishing projects.
Yes, turnkey.
Let's demystify that for the listener.
Yeah.
What does a turnkey project actually mean when you're standing on a factory floor looking at a train?
In the context of heavy railway manufacturing, a turnkey project means the customer, whether that's Indian Railways or a major OEM, hands you the empty, bare metal shell of a train coach.
Just an empty box.
It basically looks like an empty steel tube. Turnkey means Airflow takes total ownership of everything that goes inside that tube.
Everything.
Everything. They are responsible for coordinating the structural design of the interior, the sourcing of the raw materials, the fabrication of the ceiling panels, the construction of the modular toilets, the seating arrangements, the lighting fixtures, and the overall project management of the installation.
That is a lot of moving parts.
It is. They have to deliver a fully finished, passenger-ready interior. The customer literally just has to turn the key, or in this case, hook it up to a locomotive, and it works.
Which fundamentally changes their value proposition. If you're just shipping a box of air filters, you are competing entirely on price. Someone else can always make a cheaper air filter.
Always.
But when you're doing a turnkey project, you're managing the physical interfaces. The overhead lighting has to fit perfectly flush with the ceiling panels, which have to align seamlessly with the air conditioning vents, which have to sit at the exact right height above the seats, all while accommodating the underlying wiring harnesses.
You've hit on the exact reason OEMs love turnkey contractors. The OEMs, let's say a Siemens or an Alstom, they want to focus on the high-margin propulsion systems, the bogies, the train control software.
The brains in the engine.
Exactly. They absolutely do not want the headache of managing 50 different small-time suppliers for 50 different interior parts. They don't want the seat manufacturer blaming the floor manufacturer when the bolts don't line up.
Oh, I can just imagine the finger pointing.
It's endless. So they want one single reliable partner who owns the entire interior subsystem. It drastically reduces the OEM's administrative overhead, and more importantly, it transfers the integration risk off their plate and onto Airflow's.
I see the appeal. By taking on the headache of integration, Airflow makes itself indispensable. And I want to circle back to that 80% reliance on Indian Railways. Even if they are doing highly valuable turnkey work, having one entity control 80% of your cash flow is inherently dangerous.
Without a doubt.
If the government decides to tighten the budget, Airflow's entire factory just grinds to a halt.
You are identifying the defining tension of their entire business model. It is an immense concentration risk. But we also have to contextualize the nature of that specific customer.
Okay, yeah.
Indian Railways is not a typical corporate client that might get acquired, go bankrupt, or suddenly decide to pivot into a completely different industry. It is a sovereign-backed infrastructure behemoth.
So the counter-argument is that it's a monopoly customer, but it's a monopoly with the full financial backing of the government and a constitutional mandate to keep the country moving.
Precisely. The existential risk isn't that Indian Railways will wake up tomorrow and decide they no longer need trains. The demand for rail transport in India is structurally embedded in the country's economic growth.
People have to get to work. Freight has to move.
Exactly. The actual risks, which we will dissect deeply later, revolve around the erratic timing of those government orders, the brutal mechanics of the tender process, and the notoriously slow speed at which the government pays its bills. But the underlying demand, that is rock solid.
Which leads us perfectly into evaluating the sheer size of the playing field. Because if you're going to put all your strategic eggs in one basket, it helps if that basket is the size of a stadium. Just how big is the Indian rail ecosystem?
The scale is almost difficult to wrap your head around until you look at the top-line revenue figures for the network itself. For the financial year 2022 to 2023, Indian Railways reported freight revenue of 1,79,500 crore rupees.
Just pause on that number for a second. 1,79,500 crore rupees, just for moving cargo.
And alongside that, passenger revenue sat at 70,000 crore rupees.
So we're talking about a transport network generating nearly 2.5 lakh crore rupees in direct revenue. That paints a vivid picture of the sheer volume of daily traffic, the millions of tons of freight, and the millions of passengers that are putting relentless wear and tear on these physical assets every single day.
It is an ecosystem of constant degradation and necessary renewal. Now, when Airflow's management talks about the future, they cite a broader rail industry opportunity of approximately 10 lakh crore rupees over the next 5 years.
10 lakh crore rupees. I have to be honest, whenever I see a number with that many zeros attached to an industry projection, my skepticism flares up.
As it should.
Yeah, that sounds like a top-down boardroom vanity metric designed to dazzle investors rather than a realistic target.
Your skepticism is warranted, and it's crucial to dissect what that 10 lakh crore actually represents. It is an aggressive, directional upper ceiling of total estimated capital expenditure.
Okay, for everything.
Right. It encompasses the entire rail ecosystem: land acquisition, laying new steel tracks, building massive concrete bridges, constructing new station terminals, and manufacturing the locomotives. Airflow is not servicing that 10 lakh crore market. They don't pour concrete and they don't lay track.
Right, they are in a highly specialized, narrow lane within that massive infrastructure highway.
Yes. Their direct, serviceable, addressable market is much smaller. It is hyper-focused on coach interiors, rolling stock sub-assemblies, and the refurbishment of existing trains.
Which is still huge, right?
Oh, absolutely. But here is the critical insight. Even that much narrower slice is an absolute goldmine, and it comes down to one specific vital data point. There are currently 200,000 existing coaches in the Indian Rail network available for refurbishment and platform upgrades.
200,000 existing coaches. See, that changes the entire growth narrative.
It does.
They don't just have to wait for the government to commission a brand new fleet of Vande Bharat trains. They have a massive installed base of aging assets.
Exactly.
It's like a company that sells replacement tires versus a company that only sells new cars. Even if the broader economy slows down and new car sales plummet, the millions of cars already out on the highway still wear down their tread and need new tires.
The tire analogy captures the recurring nature of the revenue perfectly, but honestly, in the railway sector, it's even more pronounced. A train coach operates under punishing conditions. The core metal shell of a train, the heavy steel underframe, the bogies, those are built to last for decades.
They're basically indestructible.
Pretty much. But the interiors, the seats, the automated sliding doors, the modular toilets, the overhead lighting, those face intense, daily, unyielding passenger use.
Hundreds of people cramming in day after day.
Exactly. The interiors wear out, the hinges fail, the surfaces get vandalized, and the technology becomes obsolete. The passenger-facing elements require total modernization long before the metal skeleton of the train is retired.
So even if the government decided to completely halt the production of all new trains tomorrow, Airflow would theoretically still have a massive multi-decade pipeline of work just retrofitting and modernizing the 200,000 coaches currently rolling around the country.
That installed base provides a powerful baseline of demand. And as urbanization accelerates and as virtually every major Tier 1 and Tier 2 city expands its urban metro networks, that installed base is growing exponentially.
Because more trains mean more future refurbishments.
Right. Every single shiny new metro car that rolls off an assembly line today represents a guaranteed, lucrative interior refurbishment contract for a company like Airflow 10 or 15 years down the line.
So the demand is there, the market is massive, and the replacement cycle is practically guaranteed. But this raises an obvious question.
What's that?
If the market is this lucrative, why isn't every major industrial player jumping in? I mean, if I own a massive metal fabrication plant, why don't I just retool my machines and start churning out train doors tomorrow?
It's a fair question.
Now, understand how Airflow actually defends its market share. We need to critically examine their competitive advantages, or what we often call their moats.
Dissecting a company's moat is arguably the most important part of analyzing an industrial business, because a massive addressable market without a durable moat is just a magnet for fierce, well-funded competition that will inevitably drive your profit margins down to zero.
Right, it's just blood in the water.
Exactly. Looking at airflow, their competitive advantages generally fall into two distinct buckets: technology and integration, and distribution and qualification.
Let's unpack the first bucket, technology and integration. The company claims to manufacture almost all of their products in-house. Why is vertical integration such a critical advantage here?
Mm.
Wouldn't it be cheaper to just outsource the basic metal bending to a low-cost subcontractor and focus solely on the high-value final assembly?
In consumer electronics, outsourcing makes sense. In heavy railway infrastructure, aggressive in-house manufacturing provides two non-negotiable benefits. First, it drastically reduces their dependence on third-party suppliers.
Which lowers risk.
Huge risk reduction. If you outsource the fabrication of your aluminum panels, you are entirely at the mercy of your supplier's timeline, their labor disputes, and their quality control failures. In a government contract with strict delivery deadlines, a delay from a subcontractor can trigger massive financial penalties.
You control your own destiny.
Exactly. Second, and much more importantly, controlling the manufacturing floor enables that turnkey capability we spent time on earlier. When the design engineers, the fabrication machines, and the final assembly teams are all operating under one roof, the feedback loop is instantaneous.
Oh, so if a part doesn't fit, they just walk down the hall.
Yes, they can iterate faster, they can ensure incredibly tight manufacturing tolerances, and they can manage the complex physical interfaces of a coach interior much more effectively than if they were trying to coordinate across 5 different companies in 5 different cities.
That makes total sense on the operational side. But what about the second bucket? Distribution and qualification. The documentation mentions a certification called IRIS and points to a track record spanning over 2 decades.
This is the real barrier to entry. IRIS stands for the International Railway Industry Standard. It is a globally recognized, punishingly rigorous quality management system specifically designed for the railway sector.
So this isn't just a generic ISO 9001 certificate you can get by hiring a consultant to fill out a stack of paperwork.
Not even close. In railway and defense manufacturing, the overriding currency is trust, and the baseline requirement is absolute safety. Think about the physical reality. A faulty, automated door on an urban metro train moving at speed, packed with commuters, is a catastrophic, headline-making event.
A total disaster.
Right. The procurement agencies, whether it's Indian Railways or a private OEM, cannot take a chance on an unproven supplier. You cannot just set up a massive factory tomorrow, buy a fleet of state-of-the-art CNC machines, and successfully bid on a multi-core train interior project.
Because you have no history.
Right. The agencies mandate an audited, certified quality system like IRIS. And beyond the certification, they require a provable history of safe, on-time, massive-scale deliveries. Airflow has been grinding away at this since 1998.
That's a long time to build a resume.
It is. That 20-plus year track record of delivering critical components without systemic failures is incredibly difficult and incredibly time-consuming for a new entrant to replicate.
Okay, I understand the friction involved. It's a moat built on regulatory compliance, historical trust, and deeply audited systems. But let me push back on how durable this moat actually is.
Sure.
They don't have a secret, patented technological formula. They haven't invented a magic, frictionless train door that defies the laws of physics. They're just very good at bending metal to a specific standard. Does this mean a larger player with incredibly deep pockets, say, a massive conglomerate like Tata or Reliance, could eventually just buy their way into this space?
It's possible, yes.
Couldn't a giant just build $1 billion facility, hire away all the best engineers, eat massive losses for 5 years to build their own track record, and eventually crush Airflow?
It's a brilliant question, and the hard truth is yes. Theoretically, a deep-pocketed industrial giant absolutely could muscle their way in. There is no structural impossibility preventing it. Airflow does not possess a durable network density moat like a social media platform where every new user makes the network inherently more valuable.
Right, there's no lock-in effect.
None. And furthermore, their claims of having a distinct cost advantage are not rigorously backed up by peer comparisons in the broader industry data. Their moat is entirely based on operational execution.
So they don't have an impenetrable fortress. They have treadmill. And they have to wake up every single morning and run faster and execute better than anyone else just to stay in place.
That is the perfect way to visualize it. Their defense is their ability to simultaneously combine complex design, global material sourcing, and flawless physical installation on a rigid government deadline, while never once failing those strict safety compliance standards.
A very complex ballet.
It is. It's difficult to copy, but it is certainly not an invincible, monopolistic moat.
Okay, so they are running hard on this execution treadmill. And if a business truly has an execution-based advantage, we shouldn't have to guess. We should see the results clearly reflected in their bank account. Let's look at what happens when these integrated interior projects actually translate into revenue, because this is where the story gets incredibly compelling. The financial engine of Airfloa Rail Technology.
The growth trajectory outlined here is nothing short of explosive. Let's trace the top-line revenue over the last few years. In the financial year 2023, their revenue sat at 95.33 crore rupees. By FY24, they had grown that to 119.3 crore rupees. And then, in FY25, revenue surged to 192.4 crore rupees.
Jump from 119 crore to 192 crore in a single year. That is a 61% revenue growth rate.
It's massive.
Achieving 61% growth in a software startup is impressive. Achieving 61% growth in heavy physical manufacturing is staggering.
Truly staggering.
And what's even more surprising is that their profitability isn't just keeping pace with that revenue, it's accelerating past it. Profit after tax, or PATE, was a mere 1.49 crore rupees in FY23. In FY24, it jumped to 14.3 crore rupees, and by FY25, it hit 25.56 crore rupees.
To truly appreciate the scale of that improvement, we have to look at their margins. By FY25, their EBITDA margin, which is the best metric for understanding their core day-to-day operational profitability before accounting for things like debt, interest, and taxes, was sitting at a remarkably robust 24.6%.
24.6% on bending metal.
Yeah. And their bottom line profit after tax margin was 13.3%. Remember, just 2 years prior, in FY23, that PATE margin was practically non-existent at 1.57%.
How does a heavy manufacturing company go from barely scraping by with a 1.5% profit margin to clearing over 13% in just 24 months? Did they discover a way to make train doors out of thin air? Or did they just double the price they charged the government overnight?
Neither. The secret to that massive expansion lies in the mechanical reality of how factories work, specifically a concept known as operating leverage. Let's visualize the factory floor. In a heavy industrial business, you are burdened with massive fixed costs. You have to pay the lease on the massive facility, you have to pay the monthly financing on the million-dollar automated cutting machines, you have to pay the salaries of your core engineering team, and you have to fund the entire compliance and quality assurance department.
Regardless of whether the factory produces 10 train doors that month or 10,000, the cost to turn the lights on is exactly the same.
Correct. So back in FY23, when their revenue was hovering around 95 crore rupees, those heavy fixed costs were consuming almost every single rupee of gross profit they made on the actual parts.
Eating it all up.
Yeah. But as they won larger tenders, and as they pushed more volume through that exact same factory, pushing revenue up to 192.4 crore rupees, something beautiful happened. Those massive fixed costs didn't increase. They were suddenly spread out and absorbed across a much higher volume of output.
So once they cross that break-even point and cover the fixed costs, almost all the profit from every additional unit they manufacture flows straight to the bottom line.
That is the magic of operating leverage. It is a double-edged sword, but on the upswing, it drives phenomenal profitability. And you see this efficiency reflected in how effectively they deploy capital. The data shows they are generating returns on capital employed in the high 20s to low 30s% range. They are a highly efficient machine at turning raw capital into operational profit.
On paper, it looks like a pristine, high-octane financial engine. High growth, expanding margins, excellent capital efficiency. But this brings us to the most critical juncture of our deep dive, because buried in all these spectacular growth metrics is a massive, glowing red flag. The catch.
The catch fundamentally alters the entire financial narrative, and it centers on a seemingly obscure accounting metric known as debtor days.
Let's break this down clearly for the listener, because understanding this is the key to understanding the entire business. What exactly are debtor days, and why are Airfloa's numbers a five-alarm fire?
Debtor days simply measure the average number of days it takes a company to actually collect cash from its customers after it has successfully delivered the product or completed the service.
The time between sending the invoice and cashing the check.
Exactly. It is a measure of how fast money moves from an invoice into a bank account. For Airfloa, their debtor days are hovering around a staggering 217.5 days.
217.5 days. Let's ground that in reality. Imagine the physical timeline. It's January. Airfloa signs a contract. They immediately spend cash to buy raw aluminum, steel, and electronics.
Cash out the door.
Right. Over the next few months, they pay their workforce to fabricate a beautiful high-tech train interior. They deliver it, let's say, in March. It is installed, it passes inspection, the invoice is sent. And then, nothing.
Just waiting.
April passes.
Yeah.
May passes. June passes. They don't actually see the cash for that massive outlay of work and materials until sometime in October or November.
More than 7 months of dead air, and during those 7 months, reality does not pause. Airfloa still has to run payroll every 2 weeks. They still have to pay the massive electricity bills to keep the machines running, and crucially, they have to buy even more raw materials to start working on the next tender they just won.
So they are incredibly profitable on the income statement, on paper, but in the real world, they are waiting more than half a year to get paid by the government bureaucracy. This sounds like a horrific trap.
It is a trap.
It's the equivalent of winning a massive lottery jackpot, but the lottery commission tells you they're only going to drip-feed you the cash over the next decade. Yet the IRS demands you pay the taxes on the entire multi-million-dollar sum tomorrow.
It creates a severe liquidity crisis. This dynamic leads directly to what the financial records identify as negative cash flow from operations. This is the golden rule of heavy industry. High accounting earnings absolutely do not equal cash in the bank. When you have 217 debtor days, working capital day-to-day, the actual liquid cash you need to survive day-to-day operations becomes a severe, suffocating constraint.
If you grow too fast under these conditions, you will literally bankrupt yourself with success. If their revenue jumps another 60% next year, they have to buy 60% more raw steel up front, pay 60% more overtime, but they won't see a single rupee of payment for those finished goods for 7 months.
They'll run out of oxygen.
The faster the engine runs, the faster it burns through its fuel reserves.
You've perfectly articulated the paradox of rapid growth in a working capital-intensive, government-facing business. If those collection times do not drastically improve, high growth consumes cash relentlessly, even when profit margins are expanding.
So what's the way out?
Well, to survive this dynamic, a company is forced into a corner. They must constantly raise new external capital, take on expensive short-term debt, or aggressively pivot into even higher margin work where the eventual massive payout can cover the agonizing financing costs of waiting.
That reality forces a strategic pivot. If they're burning through working capital while waiting on government checks, they need to find high-margin growth vectors to outrun the cash drag. Where is this future high-margin growth supposed to come from?
The strategy outlines 2 primary vectors for expansion. The first is a logical extension of what they already do, deeper penetration into premium, high-specification rail projects. We are talking about the high-profile Van de Vaart trains, the Sherrod frame sets, emerging semi-high-speed networks, and the continued rollout of advanced urban metro systems.
Which makes intuitive sense. You move away from the basic, unair-conditioned passenger cars and focus on the premium platforms where the interiors are vastly more complex, requiring biomaterials and advanced electronics, which inherently command higher profit margins.
Exactly. It's a natural step up.
But it is the second growth vector that really warrants scrutiny: aerospace and defense. The company highlights a joint venture through which they are now supplying precision parts for the defense sector, things like flight simulators, advanced cockpit panels, and structural components for armored vehicles.
This represents a massive, high-stakes strategic pivot. And to understand the logic behind it, we have to strip away the end product and look at the core competency.
Okay, explain that.
Whether you are building a train door or a piece of armored plating, the underlying skill is precision metal bending, advanced machining, and an ability to adhere to incredibly strict audited compliance standards. Moving into aerospace and defense utilizes those exact same core engineering muscles, but it unlocks access to markets with significantly higher intrinsic value and much greater pricing power.
I understand the boardroom logic. Take the skill set of building a train toilet and apply it to a cockpit panel. But I have to push back hard on how seamless this transition actually is. Bending heavy steel for a train carriage that weighs 50 tons is fundamentally different from machining featherlight titanium or aerospace-grade aluminum for a flight simulator.
It's a completely different tolerance level.
Right. The tolerances in aerospace aren't measured in millimeters, they're measured in microns.
Your skepticism regarding the physical reality of the transition is entirely justified. And this brings us to a rather glaring contradiction in how the company is presenting itself.
The math doesn't add up.
Not at all. Earlier, we established that management claims Indian Railways accounts for 80% of their turnover. Yet, in other sections of the documentation, management simultaneously claims that aerospace and defense already contributed roughly 35% of their revenue for FY25.
You don't need a math degree to see the problem there. 80% rail plus 35% defense equals 115%.
It is a mathematical impossibility.
So how do we interpret this? Is it just a typo? Or does it signal something deeper about the company's internal chaos?
It strongly signals a rapid, perhaps disorganized transition phase, coupled with highly aggressive narrative framing by the management team, depending on who is in the room. When they are talking to a conservative infrastructure investor, they highlight the safety and scale of the 80% Indian Railways baseline. But when they want to pitch themselves as a high-tech growth engine, they suddenly redefine their metrics to highlight a 35% order book or projected run rate in defense.
They want the valuation multiple of a cutting-edge aerospace defense contractor, rather than the valuation of a company that makes metal sidewalls for trains.
Exactly. But regardless of whether the true defense number is 10% or 35%, the strategic direction is locked in. They are aggressively pushing into these advanced sectors. And to fund the massive physical infrastructure required for this pivot, they went to the public markets.
The IPO.
Yes. The details of their recent initial public offering show they raised 91.10 crore rupees.
And it is vital to note the structure of that IPO. This was a fully fresh issue. There was no offer for sale component.
That's an important distinction.
It is, because this wasn't a case of the founding family hyping up an aerospace pivot just to cash out their shares and buy a fleet of luxury cars. Every single rupee of that 91.10 crore went directly into the company's treasury. So what are they physically doing with that cash?
They are funding a massive physical expansion, they are building a brand new manufacturing facility, and they are moving their operations to double shifts. They desperately need to increase their physical throughput capacity to execute on this complex new mix of high-speed rail, metro, and defense orders.
This is where the operational risk skyrockets. Let's think about the reality of moving to double shifts. It is one thing to run a factory making train doors from 9 a.m. to 5 p.m., with your best, most experienced engineers watching every machine.
Right, your A-team.
Yeah. It is an entirely different beast to try and manufacture micron-precise aircraft cockpit panels at 3 a.m. with a newly hired night shift, while simultaneously opening a brand new facility, while also trying to manage a crippling 217-day cash collection cycle. Aren't they risking spreading their operational talent incredibly thin?
That is the ultimate existential question for Airfloa right now. Scaling heavy manufacturing is violently difficult. When you introduce a night shift, you aren't just doubling output, you are doubling the wear and tear on your expensive machinery, drastically shrinking your maintenance windows.
Machines break down.
They do. You also introduce profound quality control challenges because your senior oversight team cannot be awake 24 hours a day. And when you attempt the scale up while pivoting into aerospace, where, as you noted, the compliance and tolerance requirements are exponentially stricter, the hurdle becomes immense.
Because the margin for error disappears. If a train door doesn't shut perfectly, the train gets delayed at the station and people complain on social media. If a cockpit panel fails or an armored structure has a microfracture, the consequences are catastrophic. The quality control has to be flawless every single time.
Flawless execution at scale is the hardest thing to achieve in industry. Which brings us to the final, sobering perspective of our deep dive. We've talked about the massive market, the impressive margins, and the ambitious aerospace pivot. But what could actually derail this momentum? Let's look closely at the brakes on the train.
We've already exposed the massive vulnerability of their cash flow and the 217-day debtor cycle. But beyond just waiting to get paid, there are deep structural vulnerabilities baked into how they acquire their business in the first place.
Heavy reliance on government tenders. This is the sort of Damocles hanging over the entire business model. It exposes them utterly to sudden policy shifts, bureaucratic approval delays, and the unpredictable swings of election cycle infrastructure spending. We need to clearly understand the brutal reality of operating a tender-based business.
Walk us through the physical mechanics of a tender. Why is it so inherently dangerous to a company's margins?
Imagine Indian Railways needs to completely refurbish the interiors of 500 aging passenger coaches. They publish a public tender document specifying the exact technical requirements, the materials to be used, and the delivery timeline. Airfloa, leveraging all their expertise and in-house efficiency, calculates their costs and submits a sealed financial bid.
Okay, standard bidding process.
But here's the brutal part. Even with their pristine IRS certification, even with their 2 decades of flawless turnkey execution, the government procurement process is overwhelmingly weighted towards selecting the lowest qualified bidder.
Yeah.
You're only ever as good and as profitable as your very last bid.
So all that expertise doesn't give them pricing power, it just gives them the right to enter the arena. If a massive competitor, say, a huge multinational that decides they want to aggressively buy market share in India, decides to slash their prices to win a marquee Van de Hart contract, Airfloa is trapped.
They face an impossible choice. They either refuse to match the low price and lose the massive revenue entirely, which leaves their new factory sitting idle and destroys that beautiful operating leverage we discussed, or they capitulate.
They cut their own throat.
Essentially, they match the competitor's cutthroat price and willingly destroy their own 24.6% profit margin just to keep the machines running and the workforce employed.
It creates a perpetual race to the bottom on pricing. And the rigid nature of the tender system exposes them to another massive risk, the volatility of input costs. The business relies heavily on global commodities like steel, aluminum, and specialized electronic components.
Let's illustrate how dangerous this is. Imagine Airflow bids on a massive contract in January. They meticulously calculate their bid based on the spot price of aluminum that day. They win the tender, and their selling price is legally locked in with the government.
Locked tight, no going back.
Right. However, the actual physical manufacturing of those train interiors isn't scheduled until July. Now, suppose a global supply chain crisis erupts in April, or energy prices spike, driving the cost of raw aluminum up by 35%. Airflow cannot call the government and renegotiate.
The government won't care.
Exactly. They must purchase the expensive aluminum and deliver the finished product at the price they promised in January. They eat the entire 35% loss directly out of their profit margin.
That is a terrifying scenario.
Yeah.
Now, earlier we praised their strategy of manufacturing everything in-house. Does that vertical integration protect them from this commodity trap?
It acts as a slight buffer, but it is not a shield. Because they fabricate the panels themselves rather than buying pre-made panels from a middleman, they capture a bit more margin to absorb the shock. But at the end of the day, they still have to buy the raw aluminum ingots or the rolled steel coils. They cannot escape the gravitational pull of global commodity markets.
And we know definitively that this business is highly vulnerable to external macroeconomic shocks. The data clearly highlights a history of severe cyclicality. During the COVID-19 pandemic, when government priorities shifted and infrastructure spending paused, Airflow's revenue dwindled sharply. If the government pauses, the factory starves.
Furthermore, as the broader Indian rail market formalizes and becomes more lucrative, domestic and international competition is intensifying relentlessly. To protect those precious high margins, Airflow is forced onto a treadmill of constant innovation.
They can't sit still.
No. They must perpetually push into higher tech, premium segments like defense and semi-high-speed rail. If they ever stop innovating and settle for making basic, commoditized sidewalls, newer, leaner entrants will inevitably erode their margins.
There is one final element in the company's structure that we need to evaluate under the lens of risk, and that's the management team itself. The company is fundamentally family-led. We have Venkatesan Dakshinamurthy serving as the chairman and managing director, with other family members occupying key roles like joint MD and whole-time director, alongside just 2 independent directors on the board.
While a family-led structure often brings deep generational commitment and a willingness to make long-term investments that quarterly obsessed public companies might avoid, it also inherently concentrates decision-making power.
Which can be a bottleneck.
Exactly. As Airflow attempts this high-wire act scaling revenue by 60%, transitioning into aerospace tolerances, managing a brutal 217-day cash cycle, and moving a massive workforce to double shifts, the sheer bandwidth and specialized capacity of that specific, tight-knit management team to oversee such vast, diverse, and complex operations will be severely tested.
I want to pull all of these threads together because the picture we painted is complex. We started this deep dive looking at a company that resembled a financial rocket ship. 61% revenue growth, profit margins expanding from 1.5 to 13%, aggressive expansion into aerospace.
It looks amazing on the surface.
It does, but when you look at the brakes on the train, the downside scenario doesn't look like a sudden spectacular explosion. It looks like a slow, agonizing bleed. The thesis breaks if government payments get delayed just a little bit more, stretching that 217 days to 250 days, strangling their working capital.
It's just choking them out.
Right. It breaks if a sudden spike in aluminum prices wipes out the profit on a locked-in tender. It breaks if a deep-pocketed competitor underbids them on a crucial metro project, forcing their new, expensive double-shift factory to sit idle. If those things happen, that incredible operating leverage violently throws itself into reverse. The massive fixed costs remain, the revenue dips, and the profits evaporate overnight.
You have articulated the exact tightrope they are walking. It is a business endowed with incredible forward momentum, but it is built on a foundation that requires constant, flawless operational balance to survive.
It is a truly fascinating duality. On one side of the coin, you have Airfloa as a rising industrial powerhouse, perfectly positioned to ride the massive, multi-decade wave of India's infrastructure modernization. They possess impressive 24% EBITDA margins, the serious technical chops required to execute complex turnkey integrations, and an ambition that stretches from the railway tracks all the way into aerospace.
It's a huge vision.
It is. But on the exact opposite side of the coin, they remain inextricably tethered to the agonizing cash collection cycles of government bureaucracy and the relentless margin-crushing pressure of the public tender system.
It perfectly encapsulates the gritty reality of heavy industrial manufacturing. Success is never just about how well you can bend the metal. It is entirely about how well you can survive the ecosystem around it.
Well said. And that brings us to our final thought for this deep dive. We've spent this entire time dissecting Airflow's journey up the physical value chain, moving from basic metal air filters to highly integrated train interiors and advanced aerospace panels. But I want to leave you with something to chew on, a thought to ponder long after you finish listening.
What's that?
As the future of transportation becomes increasingly and irreversibly digitized, where the true value of a train or an aircraft is driven not by its seats, but by passenger data monetization, onboard AI systems, predictive maintenance algorithms, and closed software ecosystems, will hardware integrators like Airflow always be able to command these high margins?
That's a great question.
Or are we heading toward a future where incredible physical engineering simply becomes the commoditized low-margin metal wrapper for the massive tech giants who truly own the passenger experience? Keep a very close eye on how much software inevitably sneaks into their hardware over the next 5 years.